Excellent.
Well, good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by JFrog. My name is Cody, and welcome back to Techstrong Learning. Before we dive in, I have just a couple of housekeeping notes I'd like to review with everyone. First off, we are recording today's session. So if you happen to miss any of our conversation, if you'd like to watch again at a later point, or if you'd like to share with your team, you will be receiving a copy of the on-demand via email shortly after we conclude this live session today. Now, if you'd like to engage with us, you have a few options to do so. The first option is also the easiest option, and that is the chat tab. When you find that chat tab on the right side of your screen, I'd like you to let us know from where in the world you are joining us today. Now, if you have any specific questions, we do want you to send those into our Q&A section. Sending your questions to the Q&A helps us keep track of all of them that come in, and we'd really like to do our best to address as many as we can. Additionally, we do have 2 polls that we'll be launching throughout our program, so keep an eye out for those as they pop up on your screen. If you jump to the handout section, there is an additional resource there for you to download, so feel free to grab that before you leave today. And we will also be selecting 2 winners for a $50 Amazon gift card. And those winners will be selected from those who participate the most or fill out our survey at the end. So with that, let's go ahead and dive right into our topic. We'll be discussing protecting your software supply chain from code to cloud on AWS. And I'm joined today by Bill Manning, Solutions Engineering Manager at JFrog. So Bill, welcome back to Techstrong Learning. It's always a pleasure to have you. I'm going to let you run away with it.
Excellent. All right. Let me go share my screen. And Cody, thank you again. As always, great to see you. I'm super excited to be here. Let me go. Oh, can I share now? And am I sharing? I can't even tell. But all right, guys. Well, how you doing? What we are going to be discussing today is protecting your software supply chain from code to cloud on AWS. As stated, I'm Bill Manning. I'm the Solution Engineering Manager here at JFrog. Actually, not here because currently right now I'm in Chicago at KubeCon. As soon as I get done with this, I'm going to be heading over to KubeCon itself to finish off the day and then head home. But the thing is well, what are we here to discuss, really? I mean, when it comes down to it is one thing. Okay. Software supply chain, right? Your software that you build, the things you do, it depends on the software supply chain. And let's face it, right? The world today is much different than it was many moons ago when software was being created. Things change over time, methodologies, you name it, and things like that. But the one major consistent thing is the fact that your software supply chain is still the major thing that feeds your infrastructure besides your developers, right? The things that you use to create the stuff that you do. Because 85 to 90% of the software that you create as developers is somebody else's code. Right? It's this open source, free and open source FOSS software that's out there. One of the things that I always talk about when I'm doing this is the fact that, organizations, when they are building, you depend on open source projects, right? You want to be able to encourage your users to use them, but you need to have some sort of ability to make sure that certain things that you're utilizing are safe, secure, compliant, you name it. There's all the hoops you have to go through. But the thing is at the same time, one of the major parts of this that I always talk about is that developers are artisans, right? Code is what you do. I started my career as a coder. I still like to code. I still like to put my fingers in the code and build stuff. I started off as a C and C++ developer, then Java, and then, JavaScript and Node, and you name it. Now I'm working on more AI-driven components and things like that. But the thing is that as a developer, we have this naive approach, which we need to have, which is we're there to do our job, which is to solve a problem. And the thing is, we rely on these open source components to do our job, based on function and functionality is what we've been taught over time. Why reinvent the wheel when somebody else does it? And the thing is that, in this poll right here, we talk about it. Does your organization actively allow the use of open source packages in its operating system, operations and projects? Do they support it? Do they allow it? Limited permissions, or they don't allow it? Because the thing is that let's face it, every time you do a pip install, go get Maven fetch, something you're doing, the equivalent of plugging a thumb drive in you found on the street. I love this quote. I see this all the time. I love using it because it's true. The thing is that when I do a Python build or a project that I've been working on recently, and every time we do a pip install, I laugh at myself because I'm requesting these. And the thing is that when we look at software supply chain, you're inviting things into your environment that you don't know where they came from. It's like getting food that you ordered, but then getting a whole bunch of additional food that you have no idea what it is, and it just shows up at your table. And the thing is that we're constantly fighting these attacks. And we see these news and headlines all the time, right? And these news and headlines just scare the bejeebus out of everybody. And the thing is, how do we make sure that we have compliance, that we have this ability to do our jobs and do it in a way that is not going to cause issues and problems over time, right? Or, one of the things I always talk about is people are always like, well, I want my company to suffer financial losses because, we leak data, right? Vulnerabilities cost companies $4.5 million on average every year just to fix and to work on and do. And the thing is that, doing my job and doing the things I need to do and making sure that, things are compliant. And everybody talks about money, but let's be honest, actually, with all these kind of vulnerabilities and all these potential threats and things that we face as developers when we're building this stuff, it's not the financial. Yeah, financial cost is huge. It's reputation. Do you want your company to have the reputation of being data leaked or having a susceptible site, causing issues for your customers? No. Money is easy to gain and lose and gain back in corporations. It happens all the time. Reputation is 10 times harder. And think about this. There are almost 24,000 CVEs so far in 2023. 24,000. How unfathomable is that? I mean, think about this. I mean, it's like you're running uphill, and while you're running uphill, it's just a deluge of rain and mud, and everything's coming at you, trying to prevent you to do your job. And how do you delineate through that? Because there has been a 650% increase in supply chain attacks. And when I talk about supply chain attacks, it's everything from nefarious components to libraries to actually implementations or whatever. But the thing is those like typo squatting and binary spoofing. Oh, the multitude of different attack vectors is insane. And instead of it going down, it keeps increasing. Think about this. There's a 650% increase in supply chain attacks year over year. I mean, that's amazing. And how do you keep up with it? So question for you guys is, how is your organization handling OSS security today? Are you guys actively monitoring and addressing it? Are you implementing like periodic scans? Are you considering open source security, right? These are a lot of the questions we see, or not addressing it at all, right? These are things that, we hear about all the time. Hold on a sec. There we go. There's the poll. And the thing is that, every company is actively looking at these. They have to. You have no choice. These kind of questions are, things we ask our customers or potential customers every day. I mean, here at KubeCon, I think I've answered this at least 150 times within, half a day. Like, it's insane. We talk about this all the time. And the thing is that why JFrog? Right? Why us and our partnership with AWS? Well, the thing is that compared to the other tools on the market, there are tons of tools out there that can tell you that you have a piece of vulnerable library or a piece of code that needs to be fixed with like static code analysis and things like that. At JFrog, we have this complete end-to-end approach, right? And the idea is the ability for you to go in and pull libraries, third-party transit dependencies, both implicit, direct and indirect, things that you stated and all things that come along for the ride. I mean, the big joke I always make is if you're an NPM developer, you're basically having a house party. You put 3 things in your package.json, you do an NPM install, and 500 libraries you have no idea where they are show up. The other thing, too, is that by having this approach, and if you're not familiar with who we are as an organization, we've been around since 2008. We have almost over 7,200 global corporations that use us. We're in the 90 percentile of the top 100 in the Fortune 100. Top 10 banks use us, auto manufacturers. We're basically the platform that maintains, monitors those third-party transitive dependencies and the software you produce. We support over 32 package types. You can install us. You can use this as a way to move from your DC into into AWS. There's lots of things we do, and not enough time for me to go through it. But the thing is that we provide a consistent platform for corporations, from developer to device, code to cloud, whatever your division or your company calls it. But the thing is we built a solution as a core foundation for all software development, non-dependent on what tools you use. You can use whatever CI server you're using. You can use whatever CD server you're using. You can use ticketing systems, messaging systems, you name it, we integrate into it. And that's actually made us extremely popular with most people, because we realized early on in the company when we started this is the fact that we said, okay, no two companies are alike, but they all suffer from a lot of common problems. Why don't we provide them with the foundation in which they can build the most solid DevOps organization? Actually, it's funny, as we were founded before the term DevOps came out. DevOps organizations can do, right? Providing a way to provide more consistent, scalable, and secure software. So when you look at managing your software supply chain, you got to think of it this way, right? This is, you go from left to right. You always hear a shift left, which we'll talk about in a bit. But the thing is when you build your software, that 85 to 90% of stuff comes from public repositories, whether it's npm.js, Docker Hub, if you're doing Go and Rust, or you're doing Swift and you're doing like Swift 5.7 and above, where you need the package management, whatever it is, you're pulling in stuff as a developer, you're utilizing it, you're building your software, you're releasing your software, and you're distributing it somewhere, right? Either there's a device, it's code, it's cloud, whatever. The thing is that almost every organization has the same linear path they go through, the SDLC, the software development lifecycle, but everybody's different, right? And that's the thing. But when you look at this, you have to ask yourself the question, what are the attack vectors that could be happening? These are all the attack vectors, whether it's malicious packages that you're bringing in, zero-day vulnerabilities, like things like when Log4j came out, that was a huge one, right? Everybody knows that one. CVEs, the CVEs are vulnerabilities and exposures. Like one of the things you should know, by the way, I am very biased on a lot of these security things. JFrog is a CNA. We are a CVE number authority. We have a huge research team that we're out there actually actively helping companies deal with these potential security threats. We're going to talk about secrets. Think about this. How many times have you accidentally put in or how many times, not accidentally, how many times did you put in a hard-coded variable, or like a value for like an API key or something for testing, right? Those kind of things. Misconfigurations. Did you deploy a Docker image hosting your application and you forgot to configure your Nginx server with TLS? Any of the things you make, a binary, right? Everything down to production. These are all potential areas. Every little red guy you see in there is a potential threat attack. It is not just a singular focused event. It is a thing that can happen through the entire life cycle of the products you build and make, right? And this depends on also the internal dependencies and whatnot. So understanding how your code was created, the things you used to create it, how it's been pushed through the cycle of its life cycle, all the way down to its deployment, its eventual consumption, is the things that we're protecting you against as a company, as JFrog. And being in conjunction with AWS, we're helping enhance that potential for companies to go out and build the software the way they can. And by the way, just so you're aware, it's not just a single, say, region in AWS. It could be a hybrid approach where you're on-prem and AWS. It can be multiple regions of AWS. I have a customer right now that's in I think 7 regions of AWS, where they have developers spread across the world, and they're using our products in each one of those regions and replicating all the things they do in every location, so that every developer has the same set of components and things they use to build the software. We've helped increase their actual ability to do it, but at the same time, we also make sure that in every single one of those locations, they have that same ability to have that same level of security. So when we look at this, I'll explain our platform. So we have JFrog Artifactory, which is our core component. It's the cornerstone of our company. We call it the Universal Binary Repository Manager. It acts as, number one, as a proxy for those third-party transitive dependencies that your developers use. Like I said, we support over 32 package types. It also is a place to store the builds you create. And when you store the builds or any binary, we'll just say binary, right? We call ourselves the Universal Binary Repository Manager. Basically, anything that goes into Artifactory gets cataloged and correlated. We actually take all the pieces and anything you ingest into Artifactory, we tear it apart, and we turn it into a unique SHA-256 checksum, and we store it that way. And the reason why I'm bringing this up is it allows us to do a bunch of different things. First of all, we never duplicate binaries. So if you have 1,000 projects all using the same common core library, it means that we store it once and we reference it 1,000 times. This also means you could apply more context to the usage or the actual things you put into Artifactory, which is queryable. So you can add more metadata on top to make things more relevant to you than just some generic usage. The other thing about it too is that it also allows you to move things around inside of Artifactory, and all you're doing is metadata. And as I also stated, everything is actually queryable. And by the way, it's all API driven. And we also have a JFrog CLI in which you can do things too to interact with this. You don't just have to use a UI, you can use a lot of series of tools. Now, why did I explain the reason why we store the things as a checksum? Well, our X-ray product. Our X-ray product is actually amazing. And the thing is that most compliant software products, there are tons of on the market that will look for vulnerabilities and things like that. But the difference is between our products and the other is that our X-ray product is built for scale and speed because it doesn't actually use the physical, tangible component. It uses the metadata representation. And as I mentioned, we're CNA, so we have a massive database of potential threats, vulnerabilities, and everything that we do that we give to our X-ray products. And based on rules and policies that you can design as an organization, what we do is that we use that metadata to metadata comparison for extreme speed and accuracy. But the other thing, too, is most other tools on the market are action-based, meaning you have to do something to get something back. With our X-ray products, it's continuous security. It's constantly evaluating. And we're constantly updating our database, meaning that if a 0-day comes out, you get notified immediately. And because we actually map everything as metadata, it also lets you know where are you being infected and what is the blast radius. Because in most cases, the component itself might be used in multiple different projects. And this lets you know that if you do have a vulnerability, here's everything it's touched in its entire lifetime, right? Every single build, every single component over time. And it's not just security, it's license compliance. And there's another thing I love, which is something that we do. It's also called operational risk. We also make sure those libraries are, these open source libraries that are out there, just so you know, over 70% of these libraries themselves are old, outdated, or end of life, meaning that if you have an issue and a bug you find with a library and it hasn't been updated since 2009, you can be notified about that. Well, with our product catalog that we have, when we are doing this, we can also let you know, hey, by the way, this library you're using hasn't been updated to 2009, and you can write rules and policies to exclude that. This also carries over to a product that we have called curation. Think of curation as a firewall to your organization where you can write pre-evaluation rules to stop any of these components from coming in. We have tons of, if you need to look at that, go to jfrog.com, look at our curation page, and you'll get the idea. But it's really an amazing product. Everything from licensing or don't give me the latest ones, lots of things. But think of it as a way to set up rules and evaluation before things come in. Now, to the right of this, we have distribution and connect. These are consumption points. Distribution, we have lightweight immutable edge nodes that you can deploy anywhere you want, and deploy the software you need to go. So in other words, say you're deploying a web service. You have Helm charts, Docker images, and say Terraform to do configuration. You can package those up, send them to our distribution hub, send them to those the edges themselves, and stand them up in like EKS and any of your AWS infrastructure there. Or you can use our JFrog Connect for IoT platform, and the IoT platform called Connect allows you to do remote management, remote diagnostics. It all allows you to do things as like remote updates. It's used in a lot of companies, actually. It's probably one of the most powerful but simple to implement device management systems, updating and security, and like I said, remote diagnostic, including the ability to remote shell into actual devices. I have a whole webinar based on IoT management and another thing, but you can go take a look. And below that, we have pipelines. Pipelines is our CI, CD, and CI orchestration tool. But the idea here is you can either use it as a CI. It's all YAML-based. It's built for scale. It uses Kubernetes, and you can design your runtime to be like CentOS-based, Debian-based, Windows-based. And it allows you to scale and build, but you can make it templatizable. There's no plugins, so it's all direct native integrations into other third-party tools. And you can also use it as an endpoint for your existing CI system, so you can see how CI jobs are dependent on each other. But now that I gave you the quick overview of the platform, that means that the first part of this whole saga is the idea of protecting the developer and when they create their software. So we have things like our ID plugin to protect them. I'll show that in a few minutes. We even have for Git, we have a thing called Frogbot. And Frogbot is a way for you to do, it's like Dependabot on steroids. You can use it for GitHub, you can use it for Bitbucket and any other VCS, but the idea is being able to check the stuff that you do, not only from a perspective of, is there a third-party transit dependency, but we also do things like static code analysis in our higher tier platform. And then on top of that, when we go through and do all this, one of the other big things about this is I mentioned that we decide, how we can map all the pieces and components that you do, so you can even produce a software bill of materials for the things that you do for your compliance perspective, both CycleMDX and SPDX format. Because we have that system of record through the entire process, it allows companies to easily go through, create rules and regulations, security fixes and vulnerability fixes. I'll show you some really cool things that we have. One of them is called contextual analysis. Whenever I show this, it usually blows people's minds. And then on top of that, we have software bill of materials, as I stated, which is a way for you to provide system of record. And like I said, if you're not being requested for it now in certain industries, you will be. It's coming. This was the software compliance thing. We also, I don't know if you guys have already read, I'm actually reading it right now, which is the new also AI guidelines. In the United States, by the way, if you want to work with the US government, you need to provide a software bill of materials when you do work with the government. So we've actually had this for years, and now it has a name, right? It's very interesting. So X-Ray, with our X-Ray product, you can do software bill of materials. We do also license compliance searches, right? So being able to write rules and regulations around how licenses are being evaluated, by your legal team. You can have X-Ray actually do the evaluation for them. Trust me, it'll make your legal teams happy. It'll make you happy so that you don't have to go and try to track this stuff down. I mentioned you can write operational risk policies, meaning that you can go in and say, please tell me how old, outdated, or end of life my libraries are. We look for things like malicious packages. So if you've worked with Python, occasionally you hear these stories, about Python packages bringing in malicious malicious components or nefarious components that could really ruin your day. And then of course CVEs, right? The standard vulnerabilities. But one of the other things we're going to talk about today is, when we talk about these kind of components, is we're going to talk about ways to protect yourself. And I'm going to show you some examples behind that. But these are all the things that we have that you can utilize just from our default product itself. Now, with malicious package detection, this is something that it's really funny is that most of the time people just look at some of the standard package types and things like that. But what we've done is that we are a CNA, right? We're CV number authority. And most companies out there who provide this kind of data, level of data, they just scrape. They just scrape it, and things like that. We actually go ahead and in our research team, we have a lot of AI components behind the scenes, reading this information, and we're constantly finding more and more malicious packages. Actually, I'll be honest with you, the amount of packages that we're starting to find out there is starting, it freaks me out a bit. It's getting worse instead of better. I mean, we are uncovering more and more all the time. And every time I read the reports, instead of it going down, there's a lot of people are doing more and more attacks out there. And that's concerning. The thing is, you read it all the time. It amazes me too. Like, I'll talk to a lot of people in the industry and they get it. Everybody gets it. But it's like, it hasn't been for a long time that people have actually started to really, really take it seriously. I mean, SolarWinds itself really kicked it, and that really sent everyone into a tizzy. And you got to remember, the reason why everybody's more aware of it, like I'm just using, like I said, SolarWinds, was just the sheer magnitude of the attack. Over 18,000 corporations and governments that were affected by this. On top of that, the speed in which it spread. And I will tell you, it was an elegant attack. But the thing is, it was a fourth level transitive dependency, right? So it wasn't even an implicit. It came along for the ride. It was like, somebody installed the package, and somewhere in the upstream inside of the software libraries that were out there that were being utilized for the software they were building, somebody brought it in unbeknownst to them. It lay it in dormant state under the radar. And then it didn't become apparent until the actual software was started. And 14 days later, it kicked off the process. Like I said, I have to respect the elegance behind it, but the sheer violence in which it came about and just took over, right? Anyway, that's my whole thing. Like I said, I studied it, and I was like, God, it was elegant but terrifying. So these are all the standard stuff that we provide with our X-ray product. Now it says X-ray with advanced features. What does that mean? And this is the stuff that we recognized there was a lot of issues with security vulnerability management out in the world that were outside of the scope of what normal people see, right? These kind of normal things, vulnerabilities and risks and licensing. This is the stuff you hear every day. So with our advanced security set, we also recognize there was a huge problem too, which is, and I'll show you the example. When I show it to you, everybody has the same reaction. It's awesome. But the thing is that how do you go and make everything safe when you're constantly being slammed by the waves of vulnerabilities, right? I always equate it to being at the beach, and the waves at first seem nice and light, and then the tide starts to go out and the bigger waves come in, and you get hit by the first wave, and then the subsequent waves keep hitting you. Well, we saw this as a problem, and we looked at the sheer amount. Remember I said the $4.5 million companies spend on average fixing, right? Just in this case, most of the time, by the way, that's just investigating. Are we being affected by the potential threat that this says it is? Well, we decided to take up the gauntlet on this and say, all right, you know what? We're going to do better. Better is better, right? We want to make this better. So the first thing we're going to talk about is contextual analysis. And I'm going to show you the example. What contextual analysis is just because you have a library with a CVE, even like an 8.9, like a 9.8 and higher critical or whatever, are you truly being affected by that? And I'll show you. It's actually funny because the one example I show you, you'll go, oh my God, this is like amazing. Because the thing is, like I said, just because you get a vulnerability notification, are you being affected by it? And we'll tell you whether you are or not. We'll also talk about secrets. You would be surprised at the sheer volume of secrets that we find out there. And I'll talk about that too. Also, are you using the applications correctly? Are you truly using them right? Like Nginx, did you remember to enforce TLS? Did you turn off cores? Did you leave it in debug mode, right? Things like that. We'll also talk about service configurations. Now, services are the things that might run in the container, right? And the service you might have, once again, did you configure it correctly? Did you? Really? Like I said, did you remember to turn on HTTPS as opposed to HTTP, right? Your SSL. You left it open for beta testing. You put it into production. Did you forget to change it? And then lastly, infrastructure as code. I mentioned Terraform before. Infrastructure as code has become key to most organizations doing what they do. We actually do infrastructure as code analysis for Terraform. I'll talk about my rookie mistake for a second. Is when I was learning Terraform, I went through and I learned all about access controls. Put all these access controls in. I got super excited. I ran it. Nothing worked. Ran it again. Nothing worked. I ran it through our infrastructure as code scanner, and I forgot to turn off authorization equals none. Dumb move. And once I removed that, hey, lo and behold, the magic happened. All the work I did actually worked. So what is contextual analysis? Well, we found out that 78% of the CVEs that were top CVEs on Docker Hub were not really exploitable. They weren't exploitable. And I'm going to show you an example of this. The thing is that we just had a report that was done by Forrester, and we got a 393% ROI within 6 months of the investment, because I'll show you how you can cut down on the amount of time it takes you, because this is even fixing it. This is just determining, is this going to hurt me? And the thing is that what we do is that when we're looking at these potential worlds, we're not just looking at the libraries, we're looking at the library usage. So we have now we have over 250 pattern matches that we're doing right now, meaning that we look to see is it not only are you using the function that is potentially in question from the library, or is it a static input variable path? Is it a buffer that is being pushed into it that's going to cause it, or an input value that will queue off the issue? But it helps get rid of these stupid false positives. Oh my God. The thing is that every tool out there that I've seen outside of ours, even in ours before we introduced all this stuff and before we invested all this money into it, the amount of false positives, meaning, I have a 9.8 critical CVE on a library that I'm using. But you know what? The function that's in question, I'm not using, but it just took me 2 hours to figure that out. We'll show that. And that's the one that I always go, ugh. And on top of that, we decided to run this through, and we talked about secrets, right? Now, secrets are funny, right? These are things we use all the time: access tokens, API keys, and things like that. We ran millions of containers from Docker Hub through our system. Think about this. Look how many, these are millions of containers. And you look at this. It's insane the amount of secrets we found. Quick example. I actually downloaded a Python Docker image to run Python testing. I ran it through the scanner, and it was clean except for one thing. I suddenly looked, and I contacted the guy who uploaded it, because I went in, I found API keys, GitHub access tokens. I found the mother load of information. If I wanted to and be a malicious person, I could go out and exploit the crap out of it. So I contacted the guy, and the guy's like, no, I swear to God, my Docker image is clean. I said, did you check root history? And needless to say, that's where we found it. And I found everything. Terrifying stuff. I'll tell you right now, like I said, most of the Docker images out there have some sort of stuff hidden in them. Scary stuff. Now, the thing is that that's X-ray and our supply chain, right? These are the things that we do just out of the box. And with our advanced security, we help you make sure that section, right? That whole idea of like packaging and promotion, distributing and deploying, all things you're doing. But now we're providing this end-to-end security offering from us, and that includes things like static code analysis. This is one of my favorite things to talk about now. I'm going to show you guys some examples in a few minutes. But the thing is that we've now introduced the idea of, and it's, SaaS, standard for static application security testing. But the idea here is not only now are we telling you before, are you being affected by CVEs? What libraries are nefarious and all these kind of things? But now we'll tell you also things like, are you doing proper usage? And my example is so cool. I've got some really cool stuff. But on top of that, by having both SCA, which is software composition analysis, these are the components that you use, right? Those libraries that make up 85 to 90% of what you do. But also, too, now we also have the static application security testing, just say SAST, or I like to say static code. And I'll show you some great examples around that, because this also means that all the things you need as a developer can be all located in one space. And the thing is that by having the third-party, software packages attributed to, make sure you're not introducing something malicious or nefarious. And then on top of that, making sure that your code is there. And then on top of that, by us providing all the pieces here for JFrog security, including static code analysis, secret detection, infrastructure as code, application and service levels, CVEs with actual context on it, and application misuse, we provide the most comprehensive end-to-end coverage as an organization. So, why I use things like SAST is that, shifting left, everybody talks about it, right? It's the greatest ROI. If you find any sort of vulnerable issue in your production, is 100 times more expensive to fix than it is to fix it in the early stage. And also trusting your developers, right? Giving your developers not just a blank playing field, but giving them guidelines at least, and tools that help instead of hinder. Most tools will hinder. We try to help. And the thing is that most existing tools are okay, right? They're okay. But also, by correlating the SAST pieces with the SCA components, you really get a full understanding of the complexity of the potential security threats and issues. And some of them might be absolutely obscure. And in most cases, may not be applicable at all. And we'll talk about that. And the thing is also by consolidating tools into singular approaches, it also helps. We see a lot of, you'll hear these, remarks on digital transformation or tools consolidation, platform engineering. I give a whole talk on platform engineering, which is really just tools consolidation, approach engineering, and making sure that you have the same set of infrastructure and structures in place so that all development, the variants are low. Right. And the thing is that by providing a seamless set of tools, the idea is like keep your developers' velocity going while still ensuring security. So the thing is that we integrate into all the major IDEs that are out there. We also, we work at the source code level. There are other ones out there, but the thing is that one of the nice things about our SaaS is, we don't ship the code out. It's all done locally. You don't have to have a separate environment. Everything's evaluated. I have a whole talk on this. It also runs locally on the developer's machine. And on top of that, it's extremely fast. It's super efficient. And that's the part that really, first time I tried it, even in its beta form, I was completely blown away compared to a lot of the other tools that I've tried in the past. And the thing is by increasing the efficiency and prioritizing the things that you do, you operate better as an organization. So now we approach everything from the first level coding details also. And the thing is, I'll show you some of the examples. You guys know of all this. I just want to make sure I have enough time. So this is all the standard examples that are out there that you normally would find. And as I stated, you get a 393% of ROI on this. And I think I am actually ready to start diving into my demo. I like doing the demos instead. So I'm going to start off with a couple of quick examples that I like to do. And to do that, I'm going to go over here. So one of the nice things is before that I mentioned was the fact that, we have all these various products. Well, one of the nice things too is that we've consolidated all these components into a singular interface. Like here's Artifactory, here's X-Ray, here's our curation product, which I'll show you in a minute, our distribution and pipelines. But first thing I want to do is, because we have limited time, I want to show you some of the things that we've done as an organization to help improve everybody's experience. And to do that, I'm just going to focus in on one thing to start off with, which is I always like to start with Docker. Why do I like to start with Docker? Well, it's complex, right? It's got a lot of pieces. It's got an OS, it's got a runtime, it's got an application layer, right? There's a lot of things going on in there. So let's go ahead and I'm going to go select a repository. Now, a repository is where I'm storing things. In this case, this happens to be a prod repository of Docker images that I have. And the first thing I'm going to do is I'm going to go to this one Docker image I have. You can see there's some information here. I'm not going to go too deep into that right now. What I'm going to do is when I select it, you're going to be presented with a dashboard. Now, this dashboard is everything in terms of security around it. So if you look here, we have vulnerabilities. We actually have things like policy violations, because you can write policies where you can evaluate libraries and say, if it's nefarious, I don't want to use it. And like I said, you can do it based on things like licensing and whatnot. But if you look here, you have vulnerabilities. Here's our policies, security, licensing, operational risk. We let you know what components are being used, what's the most common licensing, and what's the most common one with vulnerabilities. And we actually bring you right to it. On the side here, I'll show you, I'll dive into these a little deeper, but we have secrets, right? We found a couple of high secrets. We have services, and we have the application. But I want to start off with vulnerabilities. And whenever I show this to people, I love showing this example. I'm in a hotel, like I said, so my network is a little slow. But I have 304 vulnerabilities in this container. Now think about this. This is a single release, a single build, and I build probably 4 or 5 times a day. Now think about that, 4 or 5 times a day. So I'm constantly fighting the deluge of library, of vulnerabilities. A new build comes out, I have a new thing of vulnerabilities. And I always ask the same question to corporations or individuals. I say, I have 304 vulnerabilities. How long, how many man hours, how many people? Because let's think of it. There's a myopic approach too, right? It's number of developers, their manager, right? The product manager, go up the chain all the way through the organization. What if these are going to delay a release? What if the release is going to be delayed, right? Because of a security vulnerability, you get done going through this and another one comes out, right? Another build and another build. But the big thing is how do you even investigate, not even fix, not remediate, not do anything other than determine, am I being affected by this? Because from everything I've read online, right? Because everything online is the way it is. Everything online says that I need to make sure I have 0 vulnerabilities in my code. Yes and no. Yes, if it affects you. No, if it doesn't. And what I mean by that is that our contextual analysis, the breakdown of these CVEs, I can tell you that out of these 304 vulnerabilities, 74% of these vulnerabilities are not affecting me, meaning I can ignore them with 100% certainty. So if you look here, it says not applicable. And if you look, this is a 9.8 CVSS score. That's insane. Well, the thing is that what we've done is we tell you that this particular CVE, here's the actual potential threat. And guys, I'll tell you, CVEs drive me crazy. Most of them are very lazy. If you look here, somebody just did a copy and paste of the summary and description and provides me with no data. Really, it doesn't. It doesn't. So my investigative work would be terrible anyway, right? Trying to figure out, is this potential issue going to affect me? Well, contextual analysis takes that information, feeds it into one of those yarn scanners that I showed you, and we say, you know what? With certainty, you are not being affected by this. You can ignore this. But if you need more information, here's some detailed information on why this is an issue, just so you can explain it if you need to explain it to a board. What about the rest, right? That was 74%. I just knocked 74% of the time out that you would need to investigate this. Think about how terrible that is. But we can help. That's what we do. But I can also tell you, we have all these ones that are applicable, right? So I've got a whole bunch here that are applicable. These are going to affect me. These are things I need to address. So I can go in and select one. We tell you that here it is. It's a high vulnerability. Right? It's a high severity. Here's the actual component. By the way, this is a Debian package. This is a base OS package. And this is letting me know, once again, oh, look, no information in the summary. But we've taken that information and we say, yeah, you know what? You're being effective because we can see all these calls being done. But you can go fix it because you can go directly to where you need to fix it. So number one, we delineated that 74% of the garbage you don't have to worry about. We did another 13% of ones you need to go in and address, and we show you where it is, and we provide you with research data so you can go fix it. We're expediting the amount of time it takes for you to go in and take a look at these and address them. And the thing is that by doing that, we're cutting down and saving corporations time, effort, and money. But then it also comes down to, remember I mentioned the secrets thing, right? Well, here you go. I just found the secret. Here's a password. It's a well-known password. Ooh, that's always exciting. But here it is right here. And what you should do is, here's the information you need to remediate it, go in and fix it, and then you can address it yourself. The other one I mentioned before, too, I'm kind of speeding up it because I don't want to keep you guys, we do have a limited amount of time. Here's an example of a service level exposure, right? If you look here, Nginx. Well, it looks like I'm not enforcing TLS 1.2 or higher. And here's where I can make the configuration change. And once again, what can happen if I don't do that? And on top of that, what can I do to fix it? So that's a quick thing. And then on top of that, of course, we have things like, software bill of materials, which is right here. I can also show you, once again, the overview, right? Once again, here's all that information. So you're presented directly where it needs to be. It can be implemented through the entire, security offering. But what's also cool is that I want to show you, it's just not here because I'm also going to show you, let me stop sharing for a second. Let me see if it'll allow me to share my other screen here. But I want to show you, too, as a developer, how we bring that same level of approach to you as a developer itself. So if I go in here, I see some Q&A, and I will go address it. It's just hard. I've got a couple of windows going on. I need to get one of those extra monitors for my travel. But I hope you guys can see my screen. But here's a Python project. And it's a standard Python project, but we have a plugin. Now this is VS Code, just so you guys are aware. Oh, I really should update it too. But our scanner went through my Python project and found things like SQL injection. Right? Here we go. Here's a SQL injection. And what's great is we show you, of course, like every other tool that's out there, how you could fix it yourself, right? So if you look here, remove this line, add this line. Or if you want to go ahead and ignore it, you just add this tag here and you can ignore the issue itself. But we also provide description information on why this is an issue. So as a developer, you don't have to go jumping into something like Stack Overflow. We provide you with all the context here. But the thing I really dig, and I know it's a total security nerd developer thing, is this. One of the other things I love is we provide evidence path. So I can click on here and show you where the attack starts. And I can show you how it goes through the code and eventually ends up at the exploit. How cool is that? Come on, guys. Like that is rad. Being able to actually see the traversal. But here, if you look here, like here's an unsafe deserialization. Or, here's a component running in debug. Or here's one that's being open redirected. Or even things like, here you go. Here's a hard-coded secret right here, right? And it basically just says, yeah, you know what? Get rid of that. But the other thing, too, is I'll show you, is that not only, let me see here, switch screens. Not only do we show that there, but we also, and I'll get to this one, we also go ahead and do things like, here's another example for NPM. Here's auth.json, right? So first of all, we also label your CVEs. Is it a direct transitive dependency like this one? Or is it an indirect transitive dependency? But watch this. Here's a CVE. If I click on it, as a developer, I know this CVE is affecting me. I know this is a risk. And here's the evidence. We provide the evidence. So it's not just blind trust. Here's the evidence. And it says this is the recommendation. Here's the actual research data that we provide. Once again, you don't have to go far. We have all the data here so you can read it. But also, too, if I hover over this, you can see how I can go in and fix it myself. Think about this. This is amazing, right? This is rapid. This allows you to go in and fix the things you need to fix more expediently. We also do the same thing when we are going ahead, and I'll just show you, we also provide the same thing with our JFrog CLI tool. So here's my JFrog CLI, and I'm doing an audit. And I can go ahead and see that something's applicable. I can see that there's some secrets I got to fix. I can see down here there's some static code that I need to go fix. Here's the file, and here's the actual line. Then we also extend this down to things like, I'll show this one more thing, even Docker Desktop. If you have to use Docker Desktop, we have an extension for Docker Desktop where I can go in and even evaluate containers and figure them out here. So this is just some of the things that we're offering now as a solution that, corporations are really, really, starting to, utilize on a regular basis. And the thing is that these are just a small touch, because one of the other things I want to show you too is, we have this idea of curation. And this allows you, like I said, it's like a firewall. Here's some examples, like any malicious packages or security issues or legal or operational. Here's like the latest things that have been, blocked by the firewall we put in place. This allows you to write policies, and the policies you write, like, specific licenses you don't want to do for specific repositories or malicious packages, or you don't want something with CVSS scores of X number or higher. Your company doesn't want you to always use the latest one. We see this a bunch, by the way, where in some cases having the latest version is good. In other cases, are like, let's vet that out a bit. But this allows you to go in and write rules proactively doing this. But also, too, once you've integrated this in, once it's inside, we're constantly monitoring, constantly evaluating, providing you with information. Like in this case, let's see, a Slack. I think Slack might be a little slow today loading. I'll let it load up and I'll come back to it. But like tools like Slack or Jira or things like that, or utilizing our other products like Frogbot, where every time I check my code in, I can have it evaluate and let me know, here you go. Here's all the CVEs that are affecting me. Here's all the information in my pull request. Also, are you contextually? Remember that contextual analysis. Is it affecting me or not? Well, yeah, here it is. Here we go. A vulnerable function in Flask. I can go in here and expand it, find out all the details. I can also do the remediation, and it lets me know exactly where it is. And also, too, we can even do things like static code analysis. And once again, we show you all the information. We show you where it is. We show you how to find it. And like I said, always having active notifications is huge. Right? So here we go. And being able to delineate. Now, there's a lot here. And normally, in most situations with this kind of level of detail and information that things are coming in, you would be constantly attacked by all this data. And how do you fish your way out? Well, contextual analysis, you can go ahead and filter out the CVEs don't matter, so you can focus on the ones that do. So you're not just chasing things to chase things, but you're chasing things for relevance and importance. Now, the thing is that on top of that and all the components, you can actually go ahead and have everything consolidated into this the way you want. And like I said, it provides a massive amount of data, a massive amount of information. And I'm just going to show you quickly as I'm talking. The thing I want to show you is that when I am clicking on here, and I'm going to show you just like an example of, like, say, a Docker image. And by the way, I love our Docker container registry. Like, this is a build. This is a Docker build that I did. But the reason why I want to show you is that, yes, this is the application layer. Just so you're aware, this is the application layer of the actual Docker image. So in this case, I'm running a Node front end and a Java back end. Our registry is pretty awesome because we actually help you delineate through this. But the reason why I came here is I want to go look at like a build that I produced. And like I said, most tools and stuff can tell you anything about what you're building and creating, but that's fine, for vulnerabilities, but also too, we tell you, oh, hey, by the way, I went from the Docker image to the application. Here's the actual build I created it. And I know that this application was used in 5 other images, but this also means that I can go to the build and say, in this case, like I said, this is NPM, right? I've got like 13 things in my package.json and 455 like transitive dependencies. Is that I want to show you the blast radius quickly, is also not only can we alert you, show you, help you remediate, delineate through the ones that don't matter, find secrets, but we also help root cause analysis if you're a security person. Like, here's a library that might be questionable, and here's all 129 builds that it's been part of. So the thing is that when you look at this as a solution, you have all this information and all these things you can do to protect your software supply chain. And the thing I want to let you know and end this with is also and I'm going to go look at some of the questions, is the fact that we integrate this all into the AWS Security Hub. We have instructions on how to do that. And it means that all that X-ray data that I was showing you, if you guys have a consolidated view that you use for all of the things that you do in your Security Hub, we actually will go ahead and integrate this. You can go ahead and use it. And it's all right there, ready for you to go. You can use it, utilize the details, the information that correlates directly back to your artifact, the JFrog platform security instance. It's awesome. We've gotten a lot of people who have given us feedback on this and like, this is phenomenal. We've gotten more data than we know what to do with. But at the same time, this is helpful data. And the fact that you help us focus on what matters most as opposed to chasing things that don't exist is really one of the key factors that we love bringing. So having this information also in the consolidated view for your security people is another selling point that a lot of people do internally. Like, our security team uses Security Hub for this. We're like, great, we integrate into it. So just to let you know, if you'd like to learn more about things like our curation product, go to our jfrog.co. You can look at curation. We're in the AWS marketplace, just so you know. So you can, if you have credits and things like that, you can go ahead and do this. There'll be another webinar in MLOps that will be in December. I'll probably be part of that too. But the thing is we'll let you know. Protecting your software supply chain is the main key core component that we do. If you have any more questions, go to jfrog.com. By the way, you can also go to research.jfrog.com, and you can see our CNA page that I love showing people. Amazing amount of research, but all I want to say is, in this case, is thank you guys for your time and ability here. I'm going to take a look at the Q&A really fast, and then we can take us out. It says, how can security, teams collaborate effectively and integrate, blah, blah, all right, into development lifecycle? Oh, we have tons of information on this. We have an academy that's free if you wanted to take, so you can integrate our stuff into all the various components. We have lots of webinars, lots of documentation. Just simply Google things like JFrog, AWS, and your question, and I'm sure you're bound to find one of our multitude of different blog posts. Performance is an issue for large artifacts exist, especially if a whitelisted. What is the best way to improve performance? Let's see here. It depends. So the thing is that it depends on how it's being hosted. There's lots of multitude of different ways. Also, too, are you using a local file store, an external database? There's a lot of configuration options that happen out there that some people have. They don't follow some of our best practices and guidelines, and we've seen performance and usually a couple of tweaks fix that. But we've also invested tremendously in performance, specifically over the past couple of years. Our performance has improved tenfold. It's absolutely mind-blowing how fast it's become now. But that's all I've got. Cody, is there anything you'd like to discuss before we end our little shindig?
Oh, I think, Bill, if you're ready to close on out, I think we can take it on home.
Excellent. Well, hey, guys, I just want to say, Cody, as always, appreciate you, and thank you for having me as part of this. Everybody who attended, thank you so much for attending also. Be safe, be wonderful, be well. Check out our sites. If you're happy to be around the Chicago area today and you happen to be at KubeCon, come by and say hi. I'll be there in about an hour. So that's all I've got.
All right, Bill, thank you so much. It's always a pleasure having you here with us. And speaking with you before we go live is always a highlight of my day. So thank you so much for coming.
Same here, man. Same here. Cheers, everyone. Be safe, be wonderful, be well.
Thanks, Bill. So to our audience, just a reminder, a couple of reminders. We have been recording today's session. We will be sending this recording over to you as soon as it's available, but you can also find it on the DevOps website at devops.com/webinars. Just as another reminder, I will be reaching out to 2 lucky winners for our $50 Amazon gift card giveaway. I'll be reviewing questions, chats, and of course our surveys. So please do fill out that survey there pinned to the top of the chat. I'd like to give a shout out to JFrog for sponsoring our program and allowing Bill to come on with us and give us his time. And to our audience, thank you so much for your time. We really appreciate you spending it here with us at Techstrong Learning. And we do hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect, everyone. Thanks again.
Bye, everyone.